Hello and welcome, brothers and sisters. I am your host, your brother, your professor, Mr. O'Neill Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, so I don't talk about geometry much, and I definitely need to make sure I do more of that. So today we're going to discuss geometry, but specifically the topic of special right triangles. There are two types of special right triangles, and I'm going to give you some game about what those things are and how they operate. So, listen with rapt attention, please. All right, so special right triangles, there are two types of special right triangles, one of them being what's called the 30, 60, 90 triangle, and the other one is the 45, 45, 90 triangle. Right, so these numbers represent their angles within that triangle. 30, 60, 90 are the different angle measurements. 45, 45, 90 are also the angle measurements. And it's called a special right triangle because 90 degrees means a right angle within it. All right, so with these two types of special right triangles, there's a relationship between the angles themselves, meaning that if you happen to know the value of one, you actually know the value of all three because they all have something in common. So let me show you. So for the 30, 60, 90 triangle, the relationship between them are x root 3, and 2x. Okay, so these refer to the sides of that triangle. One thing you should also remember when it comes to triangles is a concept called triangle proportionality. So that's a new thing. What that means is that across from the smallest angle of that triangle is the smallest side of that triangle. Across from the biggest angle in that triangle is the biggest side. And the one in the middle is the one in the middle. So there's an exact number to that. And this is the relationship. So I put them in order from least to greatest so that you can see that and can also remember them. So between these three values, x is the smallest, x root 3 is the next biggest, and 2x is the biggest. And they refer to the 30, 60, 90 angles as you see, because across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. So the next question then becomes, well, where do these numbers even come from? How do we know that this is even true? Well, allow me to show you. Because here at the Black Math Academy, we don't just tell you what you need to know, we also tell you why you need to know it. So where did these numbers come from? So the 30, 60, 90 triangle actually comes from an equilateral triangle, So you have a triangle where all three sides are the same length. So for our example, let's just call each side 2x. Let's just say, okay? So what happens when you take this particular type of triangle and you cut it in half by creating a perpendicular bisector from the top? So if I do that, line straight down, because it's perpendicular, that means 90 degrees. So that particular angle is 90. Now, since it's an equilateral triangle, it also represents an equiangular triangle. So because all the sides are the same length, that must mean all the angles are the same measurement, hence the triangle proportionality we talked about before. So because in the triangle, the angles have to add to 180, and all the angles have to be the same, divide by 3, you get each angle measurement. So 180 divided by 3 is 60. So all these measurements on the corners are 60. But since the top angle was cut in half by a perpendicular bisector, it cut 60 in half. So half of 60 is 30. 30 here, 30 there. And there is your 30, 60, 90 triangle. 30, 60, 90. Now, that perpendicular bisector we drew doesn't just cut the angle in half, it also cuts the side length in half down here as well. So actually, each of those these two pieces here, since the whole entire length is 2x, when you cut it in half, it would be x, because x plus x is 2x. So this measurement is x, and so is that. All right. So now we have our measurements, but we have one that's missing. We've got the side lengths, 2x, x and x, which is 2x, and another 2x. What's missing is the height of the triangle, the blue. Now, according to the relationship, it's supposed to be equal to x root 3. So again, how do we know that this value is even true? Well, since geometry is all about proofs, we're going to prove that. And the way to do that is to use the Pythagorean Theorem. Since it is a right triangle, both of them, on the inside, and we have two sides of that right triangle, we can use the Pythagorean Theorem to find the third side of that triangle. So Pythagorean Theorem says a squared plus b squared equals c squared. And a and b refer to the two side lengths of that triangle, and c refers to the hypotenuse of that triangle. So within our 30, 60, 90 triangle, we have x, which is a side length. 2x is the hypotenuse of that triangle because it's across from the 90. And so the height of the triangle would be the other side length. So it would be either A or B, depending on which one you want to choose. So we'll plug in the values and see what happens. So x can be the value of A, so x squared. The height we don't know, so we'll leave that as b for now, so b squared. And 2x is the value of c, so we'll plug that in, 2x squared. Now all we have to do is just solve this, and we should be able to get our answer for the value of the height. So x squared is just x squared, that doesn't change. B squared is just b squared, that doesn't change either. 2x squared is 4x squared. All right, so from here, we subtract x squared from both sides. We get b squared equals 3x squared. And to get b by itself, we have to do the opposite operation of squaring, which is square rooting. So you square root both sides. Square root of b squared is just b. And the square root of 3x squared, the only perfect square within it is the x squared part. So that can be solved by solving it, finding the value of x squared, where when you multiply it by itself, gives you x squared, which is x itself. So x comes out. The 3 is not a perfect square, so we can't simplify that. So that stays inside the radical, and that becomes root 3. So b is equal to x root 3, which happens to be the height of the triangle, the side we're missing. So now we just proved the 30, 60, 90 proportionality to be true based on these values. And that's where it comes from. Now, the 45, 45, 90 triangle. Now, where does that come from? Well, the 45, 45, 90 triangle comes from a square that you cut in half. So we have a square. And you cut this square in half diagonally. So from here to there. So because it is a square, all the corners are 90 degrees. The diagonal line that you drew cuts the corners in half. It's a bisector as well. So half of 90 is 45. 45 here, 45 there. And there is your 45, 45, 90 triangle. So we got it. Now the relationship between the sides here, according to the rule anyway, is x, x, and x root 2. And it actually makes sense, x and x being the same, because we have two angles that are the same, which means the two side lengths have to be the same. Hence 45, 45, 90, which is also an isosceles triangle at the same time. So these two side lengths have to be the same. That's logical. And then x root 2 is supposed to be the value of the diagonal inside it. So, again, how do we know that it's true? Let's prove it. So let's call the missing side lengths of our triangle x. So here's x here, which means this has to be x as well. So what we don't know is the diagonal line, the length of that value. So, because it's a right triangle, once again, we can use the Pythagorean theorem to figure this out. So, let's do that. We plug it in there, we get x squared plus another x squared equals c squared. C being the missing value of the diagonal line, since we don't know it. All right, so x squared and x squared, we can combine those, so they're both like terms. So x squared plus x squared is 2x squared, and that equals c squared. All right, so to get c by itself, we have to perform the opposite operation of squaring, which is square rooting. Square root both sides. So we get c by itself. The square root of 2x squared, because x squared is the perfect square, that can be solved, and that value comes on the outside. The square root of x squared is just x. Square root of 2 is not a perfect square, so we can't simplify that, which means it stays inside the radical. So root 2. So c is equal to x root 2, which is the third side. And there it is, folks. See, we here at the Black Math Academy, we also show you why you need to know it, as opposed to just learning, a bunch of mathematical concepts and not telling you where or why it comes from. So that makes us without peer. Don't forget to like, share, comment, subscribe, and follow to all of our social media pages, our Facebook, our Instagram, and our YouTube page. And always remember, it is difficult to free fools from the chains that they revere. Math is where it's at, y'all.